If you've ever tried uploading a long scanned PDF into ChatGPT or Perplexity and it refused or gave you half an answer, this story might sound familiar. It's natural to assume the problem comes from how big the file is. The actual reason is how AI reads documents. LLMs struggle when a document arrives in an unorganized and scattered form, which is exactly how most scanned PDFs look to them. Today, we're going to assess DeepSeek OCR, a new AI model from China that solves this problem and gives AI a different way to read documents. Traditional AI-powered document readers work by breaking a page into small bits of text and trying to understand it one piece at a time. Those pieces are called tokens, and they're the tiny text units an AI reads. This process works until you try something scanned, rotated, full of tables, or 50 pages long. Then everything falls apart. Once a page is split into too many fragments, the system loses the bigger picture and stops understanding the document as a whole. That's why you get jumbled text, missing sections, or answers that don't quite match what is actually on the page. Enter DeepSeek OCR. OCR stands for Optical Character Recognition, and it gives computers the ability to read text from images or scanned pages. Instead of breaking a page into thousands of tiny text pieces, OCR breaks it into visual tokens. Think of these as little snapshots that capture both the layout and the text together. The model can still understand headings, tables, and footnotes while using way fewer tokens. In simple terms, the system holds the layout together so the model can read the document with better structure. At around 10 times compression, it still reaches close to 97% accuracy. Even at higher compression levels, the page structure remains recognizable. Here's what happens inside. A vision encoder begins by treating the page like a photo. It breaks the image into patches and runs them through tiny filters called convolutions that pick up edges and small details. And then through attention layers that help the model understand how different parts of the page connect. There's also a set of specialized submodels, each trained to notice a specific pattern: text shapes, layout cues, table edges, or handwriting. For each page, the system only wakes up the few experts it needs instead of firing the entire network every time. This method is called the mixture of experts, or MOE. On a large evaluation set designed to test how well models read real-world documents, OmniDoc Bench, one version of DeepSeek OCR uses around 100 visual features per page and still outperforms older systems that rely on far larger inputs. It all points to a more efficient path for long document understanding. If you run a business, OCR changes how you manage documents. Contracts, forms, receipts, and scanned records move through your workflows more quickly, with steadier accuracy and without failures on large files. Workflows that used to slow you down now run with far fewer interruptions. If you're in research, this opens a new door for experimentation. You can work with longer documents without forcing the system to handle every word separately. The model reads the visual structure, which lets it handle far bigger contexts. And if you're learning AI, here's something worth keeping in mind. Text doesn't have to be processed as long strings of characters. Images carry the layout, spacing, and structure that help the model understand what the document is actually showing. DeepSeek OCR comes out of a Chinese research lab, so it naturally raises a few questions. Who handles your documents? Where do they store the data? Does that fit your company's security and compliance rules? Those are questions worth asking of any external AI service, not just this one. And because this system leans heavily on visual input, very low-quality scans or distorted pages still need some cleanup before you get the best results. Altogether, DeepSeek OCR shows how document understanding is evolving. Treating the page as an image lets the model keep the spacing, the structure, and the relationships that matter when you're working with complex files. It's a cleaner way to capture what the document is actually saying. If you want to stay ahead as AI takes on more of our paperwork and workflows, make sure you're here for the next breakdown and subscribe to the channel.
If you want to go deeper on this,
head over to the GenAI Works Academy. That's where we break subjects down properly, with practical courses and hands-on masterclasses. The link's below. We break down one research paper every week and show how it can strengthen your projects and give you an edge in a fast-moving field. Like and share this video if you found it useful. See you next week.